Welcome to our very first lesson, 1.1, Functions, Domain, and Range. Our learning goals: demonstrate an understanding of functions and their representations. Okay, by representations, we just mean the form of the function. So it could be in the form of an equation, maybe a graph, maybe a table of values, etc. Success criteria. So by the end of these next three lessons, because this is a three-part series, we should be able to determine if a relation is a function when the relation is represented as a table of values, mapping diagram, graph, function machine, or an equation by performing vertical line tests or identifying one-to-one or many-to-one mappings. And our second one is to explain the meanings of the terms domain and range and describe the domain and range for a function appropriately, stating any restrictions that may arise from real-world applications. So mathematicians, they're always looking for relationships in the world around them. These relationships help predict election outcomes for pollsters, trends and growth patterns in market sectors for investors or economists, population growth trends for city planners. So when doing so, they need to always ask themselves an important question, and it is, does the value of one measured quantity guarantee a unique value for the second related quantity? In fact, that question helps define the difference between a relation and a function, which is the purpose of this lesson. So let's first consider these two tables. Okay, we have table A, which is Neil's time worked and the amount of money earned. And we have table B, number of hours worked by 10 different students and their amount earned. Let's take a look at their graphs. So we have table A in green and table B in blue. Are there any trends in these graphs? So as you might have guessed, looking at the table A and the green graph, you can see a nice linear relationship. And what makes that special is that because we can see that linear relationship, it helps us make predictions about other values for that Neil might have worked. Okay. You can see here for the blue table, all the data is very random. Okay, and in fact, some of these points are actually directly on top of each other. Okay, that will make it hard to make any predictions for table B, because table B is just showing us the amount earned for 10 different students. So when one student works 8 hours, we can see there's a few different outcomes for the amount of money that could be earned. But for Neil gets paid a certain wage or a certain rate, and as he works more hours, his pay goes up at a constant rate, which makes it a linear function. So from graph A, can we predict how much Neil makes in a 28-hour work week? Yeah, that shouldn't be too hard. We could locate 28 and we can just draw a vertical line going up. Okay, and then read our y value on the graph. So we'll go directly across, and I'm thinking this is somewhere close to like 270. Okay, looks like it's just below 300, so about $270 would be his pay. This is just an approximation from reading the graph. If we determine the equation for Neil's pay, we could actually find an exact amount. All right, let's now look at graph B. So can we predict the amount earned for a student who worked 8 hours? So in table B, we can see there's a few entries for students that worked 8 hours, and those are plotted on the graph here. So no, we can't make any predictions about students that work 8 hours because there are many different outcomes as we can see. So if you remember in the beginning of this video, that important question that mathematicians will ask themselves when coming up relationships, it was, does the value of one quantity guarantee a unique value for the second quantity? And we can see here that this blue graph does not follow that because we have several different values for one value of x. So which relation is a function? So as you might have guessed, you could say table A or relation A is a function. All right. So some definitions here. A relation is just an identified pattern between two variables that may be represented as ordered pairs, a table of values, a graph, or an equation. A function is a special type of relation in which each value of the independent variable, the x values, correspond to exactly one value of the dependent variable, the y-axis. So what this means is each value of x can only have one y value. Okay? That's what allows a relation to be a function. That's what makes it special. Let's see if we can make some connections between the equations, their graphs, and functions. So it says complete the following tables to graph y equals x squared and x equals y squared on the same axis. So let's get those tables up first. Okay, y equals x squared. This is our basic parabola that we would have learned in grade 10. And then x equals y squared. It looks a lot similar to this one. However, x and y are switched. So we have x equals y squared. So let's go ahead and complete this table. All we need to do is take our values for x, plug them into the equation to calculate the y values. So we would get 410,149 for that. And then we can write those as ordered pairs. Moving on to the next table. So in this equation, in order to calculate x, that's what's unknown here, we need to plug the y values into the equation and then square them and then get our values for x. So completing that, we would get those ordered pairs. Okay, if you need to pause the video at any time, you may, and you can check these coordinates to make sure they work out. And now putting them on a graph together, so they're on the same axis, we would get these two curves here. Okay, so in Desmos, all I've done is plugged in the points, and I've also plugged in the equations to show that they pass through the points. So it's kind of interesting. The first one is our basic parabola that we know, y equals x squared in blue. And because x and y have switched now in the second table, instead of the parabola opening up, in the green one it opens up sideways, because now this equation is x equals y squared. So which relation is a function? Okay, so if we draw some vertical lines, okay, on the graph, it'll show us which one is a function. So recall a function will only have one y value for every x value. So what I've done here is I've drawn a vertical line and I've animated it so it's going to pass through the graphs. Okay, so you imagine scanning this vertical line across. In order to have a function, that vertical line can only touch the graph at one point. Okay, and we can see as it passes through the blue curve, it does that. It just touches at one point. But when it passes through the green one, that vertical line is then going to intersect at multiple points, at exactly 2 points everywhere. So what this tells us is the green relation is not a function because each value of x, let's say when x is 5, we would have two y values, one there and one there. Okay? So the green one is not a function. We can actually see this in the table of values too. Like when x is 9, we have a value of -3 for y. And then later on, when x is 9 again, we see a different value, +3. So it's showing us two values for one value of x, which breaks the rule of a function. We can see the blue graph definitely passes the vertical line test with that red vertical line moving across. It only intersects at one point. And we can see that in the table. We only see one value for x. That value is never repeated in the table. And each value has only one corresponding y value. So just y equals x squared is a function. All right, at this point, you will be able to go into Teams and answer your first AAL question. This is assessment as learning, meaning these do not count for marks. They are just to assess your understanding. So you will go in and you'll answer the following question. So Suzanne is unclear as to why the graphs of y equals x squared and x equal y squared are different. and why one is a function and the other is not. So your job is to respond to Suzanne. Okay. So, and that assignment, you can go in and if you want to upload some pictures, feel free to do so, or you can just answer in a Word file, and that would be fine too as well. Okay, I hope you found this helpful, and we will see you next time.